afternoon. Namaste. I'm back with the next set of lectures when we would look at the maps and numbering. This is extremely interesting for students to look at. Now, as I said previously in my the module 2, the maps are available online, so most of you can download maps. There are certain restrictions for download every month, but you can download all the maps that are available online, and you can use it for deriving a lot of informations. So let's look at maps today. How are maps represented? What is basically a map? What you should look at a map. If you have a map, what are the things that you have to look at before you start analyzing that particular map? Then how do you identify a map? What is a scale on a map? How do you identify the scale on a map if, even without knowing the scale? Okay, so that all of these things we would look at in this particular set of lectures. Now, as I said, we look at first thing is what is a map, then features of a map, then what do you mean by a topographic map, then the very important thing is the map numbering system. India and adjacent countries is the convention that we use for Indian map numbering system, that we would look at in this particular lecture. Once we have understood it, then we will look at what is the scale of a map, how do we represent that particular scale, then map creation with GIS, that is what is important. So now I am slowly starting with the how do you actually do an practical analysis of using a GIS platform. So if you can understand these, it would be easy for you to actually work on a practical sessions when we start looking at it. Okay, so map. So everyone has an idea of a map, right? So it is nothing but a plain representation of the earth's surface with a defined scale. Okay, or it can be representation of a 3D surface of the earth's surface into a 2D. Okay, in terms of having a scale, a definitive scale. So now when you are looking at a map, the oldest map in the world, known map, is Image Muno of 6th century BC in the Babylonia. So that is the oldest map that you can see available with us. Then maps are mainly classified based on scale, contents and purpose. So scale defines it, different scale of maps are there for different applications. Then you have contents in a map. For specific applications you need specific contents, and purposes, that is the main classification of the map. Different purpose, different maps are used. For example, if you see relief maps, these are in terms of elevation and undulances in that particular region. Then you have climatic maps, that is based on season, based on area, and it's very specific. And bathymetrical maps for ocean levels. Then you have weather maps like sunny, cloudy or rainy, that probably most of you have an Android phone, so you keep on looking at it probably when you start from your home to your offices or to your schools and colleges. Then you have vegetation and geological maps representing different aspects on the earth's surface, the vegetation aspect on the earth's surface or the geology of the earth's surface. Then you have the cultural maps, for example representing a population. Okay, so it is representing a population map. So for example, that map that is represented here on the screen is nothing but a population map. Okay, so this particular thing is an elevation map or a relief map, which is showing that this particular region has a higher elevation. When you see, these are the higher elevation and these are the ones with the lower elevation. You can see this scale here. So this gives you if you for example here it is 1100 meters, the white. If you can see, these are the regions, it is quite in that. And you have yellow, which is 1160 meters, which is here. And then you have dark blue, which is the highest point in this particular map, which is 1300 meters above the mean sea level. Okay, so that is what we are, and it gives you a vertical exaggeration, that is to see how are the elevation in a much differentiated way. So that is given as 4. So I hope everyone understood what's a map. There are different types of map, different ways of representation of a map. You represent based on scale, you represent based on contents, and you represent based on purpose. And when we look at a map, so anyone can work on a map, anyone can represent a map, but there are certain features that you have to always have in a map. I've seen a lot of research papers, they come out, they would not be the representation of a map would be so bad that you cannot really understand or interpret that particular map on as far as the earth surface is concerned. For example, when you always look at, the first thing you have to look at is the map body, or it is the main body of the map. Okay, so if you look at, this is the main body of the map. Okay, if you are representing this entire thing is the main body of the map, and you should give the north arrow in that particular map, which is representing, which is the northern part of that particular map. Okay, for example, I have represented here for both for Hyderabad and for India. Then you need to have a scale bar. This is a graphical scale bar with units. For example, I have added a scale bar here, which is representing every unit is approximately 62.5 kilometers. Okay, so which means that every unit on the map is approximately 62.5 kilometers. Okay, this entire scale is measuring from 0 to 1000 units. And when we look at the title bar, the title of the map is essentially very important. It actually describes where this particular map, I mean, where is the map actually representing on the earth's surface, whether it's India, whether it's Hyderabad. So for people who do not understand, maybe if you put this map in some foreign countries, people may not be able to understand which particular country is this or which particular city is this. Instead of if you give a title for this, it would give them a clear picture. Then legend, representing the meanings of the symbols used. In case you have used certain symbols here, for example, I have used a buffer for Hyderabad here, so I have put it as a buffer, as a circle. Then this particular boundary is nothing but a HMDA boundary. Okay, Hyderabad Municipal Development Authority. So this particular boundary also have represented, so that people understand why this particular shape has been considered for Hyderabad. Then coordinates and grid lines to make the boundary extend. So for example, I have put grid lines here, and I have represented a coordinate. Why some people may think, okay, why I have represented only two at two places, one at the top end corner on the left hand side, and the top right bottom right corner on the right hand side. So why only this? If you understand the way it is represented, if you know what is x here, okay, you know the entire x in this particular region, it doesn't change. So if this x is here, this is the same x here. Okay, if this is the y that is here, this entire line, it is the same y. So you know what is x and y in this particular point. Similarly, if you look at it here, it is the same y that actually goes in. Let me explain it here. For example, if you draw this point continuously like this, okay, and so it is again, it remains the same, there is no change, right? 17 degree 42 minutes 26, correct? It's a flat line, and when you draw this, it is a intersecting point. So you know what is this point. The same thing is here. Okay, the when you see here, it is 17 12 51 north. Okay, and when you look at it, it is 78 degree 12 minutes 34 east, this particular point. That is how you make out what is the latitude and longitude of the four different directions. So if you know this, if you know this, the rest can be found out, or if you know this and if you know this, the rest can be found out. So relatively you can find out what are the different locations on this particular map. Okay, so I hope everyone has understood this. Then the next thing that you have to understand is the map index, which also defines the adjacent map. Here I have not represented it because it was generated for a particular study region. I'll show you what is a map index when I come to the next set of slides. Okay, so yeah, let me. Okay, so just to give you another example of the features of the map. So now this is the main body of the map. When you see here, this entire thing is the main body of a map. I am representing Mumbai. Okay, so I have given a title. So title is already there, right? So I have given a north arrow. So this is north arrow is represented. I have added a scale here. So the scale bar is represented. Okay, now I have a legend at the bottom left corner, which is defining where are the industries in this particular entire region, where is the Mumbai admin boundary, that is the administration boundary that is there here. You see, this is the administration boundary, and you have a circular boundary that we have used. Okay, so it is giving you all the details about what is the map legend, right? So that is there, and then you have coordinates and grid lines. So if you see, this is also a grid line. So all these are grid lines. Let me erase all these things. These are grid lines. So you know this point, you know this point, you know this point. So obviously you can know this point. So similarly, these points are easily understood. Okay, so you know this, you know this. Fine. So this is what is the features of the map. So I am trying to give examples because most of the students make mistakes in terms of where the location of how do you actually put on a map. If map gives you the physical representation, so it has to be extremely accurate in terms of representation. Okay, so yeah, and when we look at a topographic, when I say a topographic map, or it is called a topo sheet to be more simpler, it is a map that is actually characterized by a large scale which shows the relief of an area by using contours, okay, and lines, contour lines, on which gives you the horizontal and vertical distances of both artificial and natural features. That's nothing but your topographic map. So what are the scales available? We have 1:25,000 scale, 1:50,000 scale, 1:50,000 scale. I'll explain what are these different scales when I start explaining the map. Topographic maps are available online, which are prepared by Survey of India. It's the sole owner and the sole distributor of these maps for India. So if you want to look at the maps, you can go to Survey of India website, as I have shown previously. Give your Aadhaar number and download the maps as you like for whichever region you would like. And when you look at this particular map here, okay, if you very clearly see this map here, and you try to understand, this map has its own legend, which is actually giving you the types of information that has been used. Okay, then it is giving you the scale here. It is, if you zoom in more, you will be able to understand. It also gives you the map numbering system, which means it says if this is a particular map that I used here, and the next map represents this part, and this map represents this part. So if you want just the neighboring region, you have to go to this particular map number to see the neighboring region. Okay, and it is 1:50,000 scale. You can see here, its a scale is also mentioned. Okay, you have the north arrow that is mentioned, and every detail about who has done it, what is a kind of a map also has been mentioned in this. So this is the entire complete map that you will have to look at when you are looking at this particular map as a region. Now just to give you some more examples of different maps, this is if you see this is a map of Mirzapur and Varanasi district, and you can see all details very clearly. You can see it as a part number as 63K12. Okay, this is representing a 1:50,000 map. So then you have this representing Mirzapur and Varanasi district. Okay, so this is representing again the 63K12. That is the part sheet number is again 63K12. So you can see these are maps, topographic maps representing different regions. Okay, so once you have understood this, now let's slowly graduate to the next set of representations of a map, how India and country representation is used. So if you see this particular representation here that is shown on the right side, you can see this how IAC works. So if you see the map sheet number is 53 is representing this region. IAC can have detail, you can have details of all of these maps in this particular region. So IAC is used to number the topographic maps sheet for India, which means for the entire Indian subcontinent is from 39 to 92. So that represents the entire Indian subcontinent. So each sheet is bounded. If for example, now if I have 1 million units on the ground, if I want to see a very coarse map, okay, so if I have 1 million, if I want to just look at the administrative divisions of different probably different states, so if I have to look at it, then 1 is to 1 million map is a very good extent. When I say 1 is to 1 million, it is representing 1 unit on the map is equal to 1 million units on the ground. That million units can be kilometers, meters, whatever the way it is represented. So in this particular if the map we are trying to see, it is 1 is to 1 million kilometers on the ground. Okay, so now 1 is to 1 million is representing 1 unit on the map is to 1 million units on the ground. So if you want to represent 1 is to 1 million map, it is represented by a number. For example, the number here 53 is representing 1 is to 1 million map of the earth's surface, that is in Indian context, which is here. Okay, if this is the Indian subcontinent, a 1 is to 1 million map of 53 number is representing that region. Okay, if you look at this particular map, this 1 is to 1 million map is 4 degree by 4 degree map, which means to say that this is 4 degree by 4 degree. If you look at it, an example given here is 28 to 32 is 4 degree map, and this is a 4 degree map. So that is nothing but a 1 is to 1 million map. So that is represented by a number 58 or 61 or 65, 66, 92, whichever map, whichever state of India or city of India you are looking at. So now once we have understood this, the next division, if the same 4 degree by 4 degree map, if this is the entire map that we have taken, this is 4 degree by 4 degree map. Okay, now if I divide this 4 degree map into 4 by 4 divisions, okay, which means to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 cells. If I divide 1 is to 1 million map that has 4 degree by 4 degree into 16 cells, okay, each cell is 1 degree by 1 degree. Okay, now let me erase this. This cell is 1 degree by 1 degree, and sorry, it is 1 degree by 1 degree, right? So now if this representation, if I say 53D, it is representing this particular map in 1 is to 1 million, and the scale of this map is 1 is to 250,000 scale. Okay, now we have a 4 degree by 4 degree map, okay, that is representing 1 is to 1 million scale. Divide this 4 degree map into 1 degree by 1 degree map, so you will have 16 boxes. Each box is representing 1 is to 250,000 map, that is 1 unit on the map is representing 250,000 units on the ground. Okay, this particular representation, if anyone writes 53C, it is representing 1 is to 250,000 map. That is how you can find out the scale. If someone is writing 58, it is representing 1 is to 1 million map. If someone is writing 58D, then he or she is representing 1 is to 250,000 units map, that is the 1 is to 250,000 is the scale. Okay, and 58D, if this is a 58 is the map number, 58D is something here. So A B C D E F G H I J K L M N O P. Okay. So now you have understood 1:1 million, 1:250,000 map. Once if you have understood this, now let me take this the same 1:250,000 map. Now once we have seen this, now let us say this is a 1 degree by 1 degree map, that is for 1:250,000 map. Okay. Now once we have understood this, now let us divide this into 16 equal boxes, something like this. For example, the first thing is, this is entire thing is 58, we divided into 16 boxes. Now we rename those boxes as A B C D, right. So now if I write 58C, it is 1:250,000. Now this particular C, I again divide it into 16 boxes, and boxes are named 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If I put 1 to 16 in those boxes, each box is actually representing, this small box is actually representing a 15 minutes by 15 minutes on ground, which means it is 1:50,000 scale. Okay. If someone represents 58C/1, okay, this means to say this is a 1:50,000 scale map. Okay. So or it is called as a quarter degree maps. It is extremely useful in terms of when you are when you are using it on a city scale. It is called a quarter degree map. So if someone says it's 58, then it is 1:1 million. If someone says it is 58C, then it is 1:250,000. If someone says if it is 58C1, then it is a quarter degree map or 1:50,000 map. So now 1 unit on the ground is 50,000 units on the map. This one can vary from 1 to 16. Okay. So once we have learnt these 3 scales, we will also the last type of representation, the lowest kind of representation that is there in India adjacent countries is 1:25,000 scale. So when I say 1:25,000 scale, for example, this let us say that I have already represented 53C, let us say 4. Okay. Now this fourth box, if I then divide it into 4 boxes where northeast, northwest, southeast, southwest, sorry, this is this represent, okay. If I take the box, this is northeast, southeast, southwest and northwest. If I represent it like this, which is this thing is divided as 7.5 minutes by 7.5 minutes. Okay. This particular referencing is nothing but 1:25,000 units. So if someone writes it as 53C/2/SE, it is representing 1:25,000 map, which means to say that it is representing the more details on the earth's surface. Okay. So 1:1 million map is 53, which is represented here. This is 1:1 million map. Then I will divide this into 16 parts. So it becomes 1:50,000. Then each box here is again divided into 16 boxes represented by numbers. It becomes 1:50,000, and each number is then divided into 4 boxes of 7.5 minutes by 7.5 minutes, representing northeast, northwest, southeast and southwest, which is representing 1:25,000 units on the ground. So this is how your map numbering system for India and adjacent countries is done. Okay. So I hope everyone has understood on how you number a particular map. Okay, so this is an example of the entire process of what I have explained. Okay, so let me revise this. You have this entire system here. This is India and adjacent country system. Okay, there are these are the maps which are actually belonging to Indian subcontinent, and if you choose a particular map that is called 53, that is an 1:1 million map. Okay, which is 4 degree by 4 degree map. Each map will cover the area of 4 degree by 4 degree. So, it is 1:1 million map. 1 unit on the map is equal to 1 million units on the ground. Now, this 4 degree by 4 degree, if you divide that 4 degree by 4 degree into 16 units and name it from A to P, then each of A, B, C, D is representing 1:250,000 units on the ground. Okay. So, how do we represent this? 53A to through P. Okay, 53A, 52B, 53C, 53D, each of them is representing the map. Okay, then this, for example, if we consider this 53C here, okay, then I divide the 53C into 16 different sections and number it from 1 to 16. Each of this 1 through 16 is representing 1:50,000 map. This is 15 minutes by 15 minutes of size, 15 minutes by 15 minutes sized map. Okay. So, this is 1 degree by 1 degree map. This is called a degree map, this is called a quarter map. Okay. Now, this map, the cell, any one of this cell from 1 through 16, let us consider 4, is then divided into northeast, southeast, northwest and southwest. This is representing 1:25,000 map, which is 7.5 minutes by 7.5 minutes. So, that is nothing but 1:25,000 map. Okay. This is how the representation is done. So, now let us say someone gives, let us say someone is working on a particular city. Let us take Hyderabad itself, or Hyderabad itself. So, Hyderabad is represented by let us say some map number here. Okay. Now, when a person is trying to work on let us say 1:50,000 map. So, if we consider the map number to be closer to, let us say 65. Okay. So, when I am writing the 55 this 50,000 map, it may be 65A slash let's 3. Okay, this is a map for Hyderabad. So, someone has already selected a map which is 1:50,000 map. So, that particular map, if you look at okay. So, let me take 16 boxes. Okay. This is as I said, it is 65A1, 65A2, 65A3 and 65A4 until 65A16. Okay. Now, if someone has taken this particular map that is representing Hyderabad, this may be, let us say 6. If someone has to find out this map, then he has to just take 65A5. If someone wants this map, it is 65A6. If someone wants this particular map, 65A8. This is how you find out which map you may need for adjacent representation, adjacent boundary representations. Okay. So, just an example that I have taken. So, you can look at how the map retrieval can be done. So, I would suggest each one of you to go to Survey of India website, download a map, also look at download my map of your region itself. Okay, download a map of your region and also look at the neighboring region. Download the neighboring map and see, you will be able to understand the details in a much better way, and look at the representation, look at how map is actually put in that particular representation. Okay. So, once we have understood this, let us move on to the next thing, that is the scale of a map. Okay. It is a basic requirement for the preparation of a plan of a map. So, scale is used to represent large distance on the paper. Scale is defined as the ratio of distance on a map to corresponding distance on the ground. that I have already said. If I am representing let's say 1 is to 50,000 map, it means to say that 1 unit on the map is 50,000 units on the ground. Okay, if I represent 1 is to 1 million map, it means to say that 1 unit on the map is 1 million units on the ground. Okay, so keep this in mind. So when we look at map scale, it may be a statement, it may be just a statement. The scale or a ratio is stated in words such as centimeters to 4 kilometers. That is, 1 centimeter is equivalent to 4 kilometers. 1 centimeter on the map is equal to 4 kilometers on the ground. It can be a numerical statement. For example, 1 is to 25,000. That's what we represented in our previous example. Then it can be in the graphical sections that we have seen in our first slides. So here, when you see this 1 unit is 500 kilometers on the ground, which means 1 unit on the map is equivalent to 500 kilometers on the ground. So now if you using this unit, you can measure what is the size, what is that particular image size. Okay, what is the area of that particular image, length from one end to the other end, etc., can be easily found out with just using the scale. That's why you need a scale for a particular map. Okay, so this is about scale of a map. Then scale is essentially a ratio or a representative factor. As I said, it is the distance of the object on the drawing on the map corresponding actual distance on the ground or of an object on the ground. If 1 meter map on the represents a distance of 100 meters on the ground, then the map is said to be 1 meter by 100 meter. That is 1 is to 100 or 1 by 100 as a ratio factor. Okay, there is one very basic thing that people don't understand is a small scale and a large scale map. Small fractions such as 1 is to 1 million shows only large features. Okay, then it is called a small scale map. Large fractions such as 1 is to 25,000, 10,000, 5,000, 1 is, if there is a map of 1 is to 5,000, it shows greater details of information, then it is called a large scale map. Okay, so please remember, the one that gives you more information is a large scale, one that gives you the very less information but only the representation is a small scale map. 1 is to 1 million is a small scale map, whereas 1 is to 10,000 or 1 is 15,000 or 1 is to 20,000 is a small scale map when compared to is a large scale map when compared to 1 is to 1 million. Okay, just to give you an example of a scale, if you look at this, the first here is I have represented here 1 inch. 1 inch is equal to 1.485 miles or 1 centimeter is 940 kilometers. So the representative fraction, if you look at, is 1 by 94,000 hundredths is what the representative fraction is there. So this is giving you the least information. It is only representing Bangalore in the entire country, India. Now I go into more details here. So it is 1 centimeter is equal to 160 kilometers. It is representing much larger fractions, and when you go here, you are getting you are able to see much more details about Bangalore, where 1 centimeter is 13 kilometers. This means to say it is giving you a huge wealth of information. That's why it's called a large scale, whereas it is just giving you the location, then it is called a small scale. So this is the difference between a small scale and a large scale map. Okay, please remember this. This is where most of the students make a mistake: a large scale and a small scale map. Okay, once we have understood this, we next part is looking at map creation with GIS. So when I look at GIS is extremely useful in terms of map creation. You can create visually, thematically very good images in terms of maps. So but only thing that you have to, all of you have to remember when you are creating GIS map is what do you want your map to show. Okay, whether it is showing a particular region, particular place, what kind of details you want to show, what are the features you want to show. And then does your map stand on its own or it is a part of a larger map? So as I have represented an India with then with Hyderabad, so it is a part of a map or it is only the map that is actually represented. What data is included in the map and what is the scale that you need, so that without that you will not be able to really represent a particular map. What scale, what is the representation of a particular map? And most importantly is who is the audience of your map. Not every audience will need every kind of map, but what are you actually targeting to? Are you representing population and showing it to someone? I mean, if you are trying to show population to someone who is interested, then you are drawing a population map basically. So what kind of representation you are trying to look at is extremely important when you are looking at maps. So that's what is very important. Then then the next thing is, how do you export a map in a GIS platform? GIS platform gives you extreme help in terms of exporting a map. You can export a map the way you need for from your using your normal formats like a JPEG, which compresses your entire image file, to so even your SVG formats, the raw formats. Easily it can be exported into any kind of formats. You can even set the amount of depth of information that you basically need, and what kind of format. For example, now the maps are being even represented in terms of the PDFs, the portable document format, which gives you a consistent viewable across the platforms. You have JPEG and PNG, where joint photography experts group and the portable network graphics, both of these are used as interchangeable formats in many of the mapping platforms. So any of these forms, any kind of resolutions that you can are there in terms of when exporting a map in a GIS platform. We look at all of these when we look at how we look at practicals. And to summarize, map is a plane representation of the Earth's surface with a definite scale. We have looked at what are the different features of a map. We started with the map body, then we looked at the title, we looked at where the scale has to be placed, then the northing, then we looked at information about the map, certain information that are required, then we look at adjacent maps also. I gave you an example of it. Then the then we looked at the map numbers that has to be represented, and the area names where it is actually located. So that is what is a part of a map. We looked at topographic map and also discussed about the Survey of India. Then we looked at map numbering system, IAC. So 1:1 million maps is represented by 4 degree by 4 degree, and is represented in terms of just a number 53, 58, 60, 65, etc. And when you go to 1:50,000, is a 1 degree by 1 degree map. It is represented by 53 A, B, C, D, or just 53A represents 1:50,000 map. And if you represent 53A1, which is 15 minutes by 15 minutes map, it is representing 1:50,000. And if you represent 53A1 northeast, then it is representing 1:25,000 map, which is representing 7.5 minutes by 7.5 minutes. So that is how the entire India and adjacent systems are placed. So this is how you do a map numbering. Then we looked at the scale of a map, a large scale map versus a small scale. Please remember this: small scale gives you very less information, whereas large scale map will give you very high detailed information. So large scale map is 1:1000, 2000, 10,000, 15,000 when compared to 1:1 million, which is a small scale map. Okay, so please remember this. Then we looked at how do we create a map in GIS, but you should look at what is the context in terms of developing a map. So this is what it means by the entire mapping system. And in the next class, we will end this particular module by discussing about what do we mean by a projection. Okay, so we'll look at the different projecting systems of projecting a 3D surface into a 2D surface, and then look at the map, look at how we can proceed with that. Thank you very much, and we'll meet in the next class. Thank you.